So now in this video, it's going to be the last video for the preliminary 2024 paper 2. And I'm not doing question 10.1 because that is clearly a theorem that you need to go over by yourself. And once you know those theorems, then you'll be able to get full marks immediately. And I'm pretty sure teachers have told you the same thing, because those theorems, you just need to remember them and how to construct those triangles such that you get whatever they want you to get, basically. Okay, now let's do 10.2, right? So 10.2 says, in the diagram, HLKF is a cyclic quad. So they're giving us that already as the cyclic quad. And now they say the chords HL and FK are produced to intersect at M. So FK and HL, which they produce, they produce to intersect at the point M over here. Okay. Now the line FG is parallel to the KL, so we can see over here they're parallel to each other. They meet at MH. Okay, so they meet at MH, which is produced at G. If you can see it over there. Okay, that is the other information that we have. And then we have MK is equal to a half. MK over KF is equal to a half. Note that that is actually the proportions of this. So MK, and then this is KF. And this is going to be 1, and this is a 2. So those are ratios, basically, right? And LH is just equal to HG, which we can see over here by the geometric symbols. Now let's start answering the questions here, right? Now, when we're starting to answer these questions, we're going to do the following. Sorry about this. 10.2.1 says, give a reason why GFM is equal to LKM. So GFM is here, right? This is GFM, and LKM is here. Now we can clearly see that because these two lines are parallel, the corresponding angles need to be equal. So we're going to say that therefore GFM, angle GFM is equal to angle LKM because of corresponding angles are equal, because once again KL is going to be parallel to FG, and that is our reason over here. This is our reason for why those two angles are equal. So now our next question is going to be 10.2.2. Prove, giving reasons that with A, that these two triangles are similar to each other. Triangle MFH, so let's just point these ones out. MFH is here. So it's going to be this triangle here. This over here, MFH. So I'm going to do it like this, right? So this is MFH in purple, and then in red, triangle MFG, which is going to be this one here. So MF, and then we're going to have G over here, like that. Okay, there's our two triangles. So now we can draw, now let's break up these triangles to see what is equal over here, right? So I would normally do it like this. Let's do MFG. MFG is like, looks something like this, right? It's the biggest triangle. And it would look like this, where F is going to be here and G is still all the way down like that. So G is here, this is F, and this is M. Okay. And then we have our other triangle. So this is going to be this is the red triangle. So I should have actually done it in red, but it's fine. And then our MFH, which is going to look something like this. If we orientate it such that it's in the same orientation as the other one, we're going to have a little bit of a smaller triangle. And then we're going to have something like this, and then like that. And the reason why it looks something like this is because we have M over here. We have H, which is raised up a little bit, and F is like this. Okay. So what we can clearly see is that these M's are going to be exactly the same because they're exactly at this point M, right? So therefore, we can already see that this angle is equal to that angle. Now we know that this F is definitely not going to be equal to this one. And the reason why is because, sorry about that. The reason why is because this is MFG and this is MFH. So those are completely different ones over here. And if one of them is F2 and the other one's F1, and that's why they're not equal. they are not common angles, right? But let's try and get two equal angles so that the other angles will be the same due to sum of the angles in a triangle, right? So let's look at this, right? We have K1, which is equal to MFG, right? We have actually proven that. So what we can actually see is that we're going to have MFG, which is equal to K1. I'm just going to write that here for now. MFG equals to K1. And let's see what else is going to be equal to K1, right? We have to have another angle, but in the other triangle. I'm pretty sure there should be another one that's going to be equal to K1. What we can see here is that K1 is actually the exterior angle of this cyclic quad. And what we know about exterior angles of a cyclic quad is that the exterior angle is equal to the interior opposite angle of that cyclic quad. So therefore this MHF is going to be K1. And hey, there we go. Now we can see that this angle is equal to that angle. And then obviously the missing angle is going to be what we're going to find. So let's start with the proof. So the first part of the proof will be that we're going to state in which triangles we're working with. So in triangle MFH and triangle MGF. And now we are going to show over here what was the first things that we have proven, right? So number one is that angle M is equal to angle M, because remember that they are common angles, right? And then number two is going to be the angle, angle MFG is going to, I feel like we were supposed to first prove this. So in number two, we're going to show all of our proofs, right? We can't just say that, oh, that's equal to that now, because we need to show what work we've done to get there, right? So first of all, the first thing we did is we know that K1 was equal to MFG, right? Angle MFG. And the reason why was because we've proven it in the last question. Remember, in the last question, we proved why they were equal to each other. Okay. And then our next step over here is going to be, because we proved that that was equal, we also shown that K1 was also equal to MHF, right? K1 is equal to MHF. And the reason why that's true is because, also here, is because of exterior angles of a cyclic quad. Okay. Now, because that is true over there, the last step is to actually show that those two are equal, right? We need to show that MFG is actually equal to MHF, which we clearly shown over here because they're both equal to K1. Therefore, we can say that MFG, angle MFG, is equal to angle MHF, and that is our second angles that are equal to each other. And obviously the third one is going to be the leftover angles, which we can say number 3. Therefore, we're going to have MGF equal to MFH. So MGH equal to, so it was MGH, MGF equal to MFH. MGF equal to MGH. MFH. This is a lot of like going up and down over here. Okay, so now we prove that they are equal. The reason why is because of the sum of angles in a triangle. Remember, that's the reason, because it is our third angle that we are missing, and because we know these two angles, we can just find it, but we know they're going to be the same anyway because the other two angles are equal to, the other two corresponding angles are equal to each other. Okay, cool. Now that we have proven that all three of the angles are equal, so then we can conclude that therefore MFH, so we're going to say therefore triangle MFH is similar to, so MFH is similar to MGF. And the reason that we used was angle, angle, and angle. Alright, so the last question is going to be question B. These are normally the most intense questions of the papers, because once again, these are to test how much you know your geometry and Euclidean geometry, to see if you know all of your theorems. And yeah, let's see why that's true. So we have mf over ml equals to root 6. That's what they want to prove, right? So let's look at the first piece of information. Now we know we need to use our proportions, right? We need to use this information over here, right? So what we are actually going to what we actually said in the beginning is that mk has a ratio of 1, and then k has a ratio of 2. Kf has a ratio of 2. It's a ratio of 1:2. And what we know over here is because these two lines are parallel, KL and FG, this whoops, wrong one. This ML is going to have the same ratio over there as the other ones, and the LG is going to be 2. And this is why that's true. So what we are saying is that MK over KF is actually going to be the same ratio as ML over LG, right? Which is equal to a half, right? That is exactly what we are saying. And the reason why we said that is because we are using prop theorem. Prop theorem is the reason that we use. I think there was another theorem, but I actually can't remember. I haven't learned it in high school, but I used prop theorem. And the reason is because which lines were parallel? We use prop theorem because KL is parallel to FG. And that is how we get ML over LG. And the reason why we did that was because this is one step closer as well to getting our ML, right? And we have ML here. Cool. And now we're going to go from here, because we did our prop theorem, but the next part is going to be that we're going to take a deeper look into this one over here, right? So let's look at this side here, right? This side here. Let me do it in a different color now. So let's look at LH and HG, right? So why are we looking at those ones? Because look at, we have a ratio on this side over here, which is 1:2. And that's where the most information comes from our given information, right? So what we are saying over here is that ML is a ratio to LG, where ML is 1 and LG is going to be 2. So what we are saying is that LG, right? LG is 2 times. So LG is actually equal to 2 times our ML. Am I right? From this information that is given over here. That is one step closer to when we are getting our answer, right? But what do we know about LG? With the most information, we can't just say LG over here. We want to prove that this is actually going to be equal to all of this. That is why I said let's look at all of this. Let's look at this side first, right? Because we have 3 sides, which is going to be LH and LG, right? LH and LG make up this side LG. Because remember, those two are exactly the same sizes, or lengths, sorry, which actually make up LG. So we can actually break that up like this. LH plus HG. Plus HG. You can see that here's the L and here's the G. We're just expanding it basically into 2. Is equal to 2 times ML. Okay. So from this information here, what we know is because we have LH, which is equal to HG, right? Because remember, this was given to us. Because this information was given to us, let me write this G properly. We know that the 2ML, right? It was 2 times ML. And we can clearly see that because LG is actually 2 times the length of ML, therefore we can actually say that because of the given information here, that these 2 sides are equal to each other to give us LG, that ML is also going to be the same size. I know I went a little bit fast there, but if you didn't get it, please just grasp the information that I've said. Go back as well if you need to, like rewind. I feel like you really need to like understand what I've said over here, right? So what I'm trying to say over here, okay, let me actually show you why it's going to be like that. I can actually do it mathematically. Remember, because I said these two are the same, let me just let these two equal to x, right? So LH is equal to HG, which is equal to x, right? And we're going to say that that's going to be, so essentially that's just going to be LH plus HG, which is just going to be x plus x, right? Which is equal to 2 times ML. And this is going to give us 2x is equal to 2 ml. And we divide both sides by 2. And then these cancel out on both of them. And therefore, we're going to have x is equal to ml. But remember that we actually know that LH is equal to HG, which is equal to x. And now that we've proven that x is equal to ml, we can say that it's equal to ml. And that is what we have over here in our diagram. That's what I was trying to prove over here. Now this is the next step that we're going to take. What we see over here, what we see over here is with our information, right? What we want to prove, we have MF. And MF doesn't fall apart of what we were proving here, right? But it does fall under our similar triangles. And ML doesn't, but we do have MF in our similar triangles. So this is what we are going to do, right? And there's a lot of information over here. So I'm going to write it over here. Okay, you know what I'm going to do? I'm going to cut the video to where we actually have the important information so that we have a lot of space and we can still see the questions, okay? All right, I'm back. So let's look at this triangles, right? Remember that if we want to look at these ratios within these similar triangles, we need to do the following, right? So we need to take the first 2 letters of each triangle and we need to divide them by each other. So it's going to be here, I'm going to write it here. It's going to be MF all over the other first 2 letters, which is MG, right? This is grade 9 stuff. You guys have learned this in grade 9. And then we have the last 2 letters of each triangle now, which must be divided by each other. FH over GF, FH over GF is equal to, and then we have the first and last 2 letters of each triangle, which is MH and MF, which is equal to MH over MF. Now the reason why we did this was because, remember that we proved that triangle, it is MFH is similar to triangle MG, what was it, MGF, right? Let me just check. MGF, yes. That is the reason why. Because once again, remember, whenever we're working with corresponding sides in proportion, right? Remember that theorem that we've learned, corresponding sides in proportion. That means that our ratios are actually equal to each other. Am I right? So that's why we use that method. And remember, the order is really important of these similar triangles. Okay, so what else are we going to look at? So we know over here, remember, MF is what we are trying to involve into this proof, right? Where is MF in our ratios? Now MF is found over here in the first ratio and the last one, which is over here, right? So therefore, let's discard this, because remember, we need to make an equation. We can't just make 3 ratios equal to each other. So we're only going to focus on the first and the last one, which we now know, which is going to be MF all over MG is equal to MH over MF, right? And now, because we have an equation, we can now cross multiply them over here. And, it's going to be MF multiplied by MF is equal to MH multiplied by MG. And we know MF multiplied by MF is just going to be MF all squared is equal to MH multiplied by MG. Okay, so now we got a nice equation over here in terms of MF, right? Let me write it like this. So let's look at our diagram again, right? So MH, where is MH? Because remember, we want to get it in terms of MF and ML, am I right? That's what we have in our ratio here. That's what we want to get it in terms of. So let's look at ML. ML is here. Not ML. MH over here. MH is here, right? We know that MH is just going to be equal to 2 times ml, right? Because once again, I'm trying to include ml only. So mh is just ml, which is over here, but multiplied twice. Okay, and then what's the next one? So that's how we're going to write it like that, right? So it's going to be mf all squared is equal to 2 times ml multiplied by, and let's look at where mg is. It should work out to give us ml times 3, I believe. mg is over here, right? So mg is here. I know it's a lot of information, but please let's get through this over here. mg is here, and we know that because ml multiplies itself 3 times to actually give us mg, it will be written as mg is equal to 3 times ml. We once again got it in terms of ml, and this is how it's going to look like now. And we can already see a clear answer here. Multiplied by 3 multiplied by ml. Okay, now over here what we are going to do is we can see that this can multiply. So 2 times 3 is just 6 multiplied by ml times ml, which is ml squared, and then we are going to do this, so it's mf squared. And remember that we need to get our thing like this. It's going to be mf over ml, right? So it actually works out perfectly. If we divide both sides by ml squared, we are going to get these cancel out over here, and we're going to have mf all squared over ml all squared is equal to 6. And if we root both sides, right, it will actually look like also plus minus, but we're going to choose a plus because it's a side. It's actually going to be looking like this. It's going to be root mf squared, because remember your properties, all over root ml squared is equal to positive roots of 6, and therefore we know that these roots over here will cancel, and therefore we have mf over ml is equal to root 6.